right? But then the majority of it's going to be, I'm actually going to kind of step you through and show you what the talk's about is turning real user measurement data and really being able to analyze that, you know, with today's data science and what technologies available. SOASTA actually took some technology, open source, and I'm going to spend most of my time talking about that. But at the beginning, I'm going to kind of talk about the product that we've kind of built on top of it, which you can do the same thing without the product, because underneath it's open source. And that's what everybody usually wants to talk about. Well, I don't want to buy anything. I want to do it myself. That's a challenge, but you can do it. So I'll just go ahead and jump in. First thing, you're going to hear me talk a lot about beacons. Everybody here know what a beacon is? I always assume yes, but just in case. So a beacon essentially is every time a user touches a mobile app or a website, data can be collected. And I'll actually show you the website where you can go read all about beacons, the W3 Web Consortium. But SOASTA, we've collected since we started doing real user measurement back at the mid-2013, we've collected over 85 billion of them. And the run rate now, when I first did this slide back in, I'm going to say like February, the run rate was about 2 billion a week. It's now 3 billion a week. So that's a lot of data. And it's continuing to grow. Projected at the run rate we have now that we'll have collected over 175 billion beacons by January of 2016. And one thing I want to say, like right up front, is we don't aggregate data. So in other words, we don't collect a minute's worth of beacons and then after a day drop everything, the resolution, and maybe one beacon per minute instead of a beacon every second or whatever. We don't do that. So the data size, that's why the data is so large. So the challenges around data science really is not just the collection of the data, it's the analysis and dissemination. It's easy, and I will show you with the open source stuff, easy, to be able to collect the data and aggregate it and store it somewhere. It's the actual analysis that takes the time. And from New York Times, they estimated that 50 to 80% of people that are data scientists spend their time essentially writing algorithms, analyzing data, slicing it and dicing it, not collecting it. It's an actual, doing the work to turn the data into meaningful data that they can use. So the challenges that we've seen in actually building something to be able to do this type of analysis, it's infrastructure, because technologies, they can take a long time to build. A couple of years, 2-3 years ago, if you were trying to actually say, hey, I want to collect real user data, I want to be able to store it at scale, you're talking about something that would cost you tens of millions of dollars a year because of storage, infrastructure, labor, and all the analysis that went into that. And that was a big challenge up until some of the technologies that I'm actually going to show you became available very recently. And then actually building that data pipeline and schema just takes a lot of time, loading the data, essentially putting the schema together, the analytics, and how to make it so that it's actually something you can touch real time. And then actually figuring out, can you ask the right questions of the data, how to visualize that, and not just an algorithm, but actually visually show that, ideally on some kind of a product where somebody can actually analyze data as it's coming in, whether it's related to retail conversions and or bad user experiences. And I'm going to actually show you a bunch of visualizations to drive that point home as well. So some of the trade-offs, really what we looked at for really what a data science, we have a product that's called the Data Science Workbench. And it's essentially what it is, it's a storage layer. It's really three-tiered storage layer. And then you have to churn in with the data somehow with some kind of a language. And one of the things we looked at, the things that are big in the market obviously are Python, everyone's heard of those, R. But the issue with those is they're slow, the technologies are old, compilers are 20 years old. They just don't have the speed that you need to be able to do to just churn through this much data. So we started looking at something called Julia. I don't know if any of you have ever heard of Julia? Yep, a couple of you. It's actually a language out of MIT, and again, when the slides get sunset here, I'll show you some of the links in the web pages, and we'll get into that a little bit as well. So we did a lot of analysis on the language that we would use and the compiler technology. And again, the reason was processing speed, the support for parallel processing. The large number of essentially notebooks and visualizations and functions libraries that were built is open source. Everybody contributes to it, and I'll show you the web page where you can actually go and see that. But also, it actually can interact with a lot of those. You can actually do function calls into C++, into R, into Python from Julia. So expertise that you have in those areas, you'll be able to carry over as well. Okay, talked about that. So in the database underneath, we use Amazon Redshift. Redshift is fairly new. Very, very cheap, as I'll show you in a minute. And they don't really charge you for putting data in. What they charge you for is the storage and if you pull data out. So it's very easy to scale, very easy to build, and again, very fast query times. And that's really what you're looking for when you're looking for something that's real time from an analytics perspective. You want it to be as quick as possible. So why Redshift? And we were at actually went to a Big Data Tech Conference in Boston back in April. And the majority of the presentations were all around big data with Hadoop and everything that's going on in that space. But that's a very good solution, but it's very expensive and requires a lot of cash, a lot of upkeep, and it's not as real time as what we were looking for. So we essentially went after the Redshift to be able to essentially store as much money economically as our customers were, because let's face it, when you're collecting that many beacons per month, it's going to add up quickly. And to be able to store a terabyte of data per month for essentially under $1,000 is pretty good, because that was something that, up until maybe a few months or a year ago, you're talking something that's a multi-million-dollar requirement for you to build a warehouse like this. So now I'll talk about the architecture a little bit, and we didn't design any of these. I just like them. So the product that we actually offer, we offer a real user measurement product called mPulse. It's been in the market for a couple of years. It's kind of based off of Boomerang and Log Normal, for those of you that remember that and still utilize that. And a component of that we have named the Data Science Workbench. And this is what essentially can take all those beacons and do all the visualization and analysis of the data in the architecture that I'm walking through right now. So what it does is it essentially comes with the technology I'm going to show you here, which Julia and Redshift they're both open source. You can go get yourself an Amazon Redshift account and download Julia, program that, and off you go. What we also do, though, is we load all the real user beacon data from mPulse into the Redshift database for you. And all the visualizations and everything that you can do, the notebooks are all done with Julia. You can do them yourself, or again, the ones that are available, we create. If we create some, or our customers ask us to create some, we make them available to everybody. And I'm going to show you quite a few of those. Hopefully everything's still up and running. But I'll show you quite a few of those today. And then you'd have access to that library as it grows. As a customer, you'd pull functions down, visualizations down, you'd create some, put them back up, much like you would in a regular open source community. So the collection architecture, essentially what mPulse does, collects all the user beacons from all over the world, aggregates them, but doesn't drop them. So it collects them, and actually we store them in 2 core areas in the US for speed purposes. So essentially what we do, we collect every customer beacon, unpack it, and we do it in the Data Science Workbench. We do it nightly, and we actually do that in the schema that we've done in Redshift, and we support it. And again, the cost is about $1,000 a month for the storage. And then you're able to essentially utilize Julia to do notebooks and function calls. And again, I'm going to show them in a second, so I'm kind of skipping through a lot of the slides here. So let's see it. So what I want to do first is just to show you. So this is the website that talks about the beacon working group, the WWW3C working group that talks what a beacon is, what is in a beacon. So any of you that aren't familiar with that, that's it right there. And then Julia Language, their homepage is julialanguage.org. And essentially they have a lot of good stuff in here, everything from downloads where you can actually download the software and learn it. This is where I learned it. They actually have a good community here where you can actually download different tutorials, read some books, You can actually, if you're a Python person, you can actually, almost like a translation, you can compare what Julia can do to Python. But it's a great community. It's run out of MIT, changes often. The other little tidbit is Julia is so new, we went up to MIT, where it's based out of, and it's actually, that's where they're building it, and I think at end of April, early May. And at the time, we were the first commercial product being built on Julia. So that's how new it is. We did a lot of analysis before we made that decision. So what I want to show you is I'm actually going to walk through some visualizations here, and this one I was kind of playing around with. And one thing we're always asked, these are all, essentially this is Julia, I'm going to walk you through these. So one of the things we're always asked is, hey, what's my peak day, my peak minute? So one of the things you always want to know in performance is you want to know what's your peak minute, peak day, peak hour, and you want to be able to essentially performance test against that. You want to know what those peaks are. And the other important thing is that what you're able to do here is you're actually able to write function calls and essentially pull data out. And here's an example of a function that we wrote, get peak. Essentially what you're doing is I want to know what my peak day is, and then I want to know what my peak hour is, which is right here, and I want to know what my peak minute is. And interestingly enough, you would think, okay, if they're going to be the same thing, the peak day, the peak minute, the peak hour, it's all going to be on the same day. It's really not. But we found out when we went through the data that your peak day may not, your peak hour may not be during your peak day. So that was data that was kind of enlightening for us, for some of our customers. And then what you're able to do for some different functions, I want to be able to see during that peak, like if I want to do it during an hour, if I want to see peak hour, I can actually utilize a function call and say, during the peak hour, this is what essentially the page group distribution was during that hour. So now you're able to start kind of formulating, what people are doing when they go to your website. Where do they start? Where are they spending their time? And then you can actually put essentially here's one for the session links. So you're actually able to glean data out from the real user experience. And then what I want to be able to understand, and this one's actually from a live customer, one of mine, is they were having a lot of problems, not necessarily during a Black Friday, but same time period every week, and the website was going down a lot. And we did a lot of different load tests on, quote, standard paths, right? Go to the landing page, do a product search, women's, product category, and then all the way down to several different options. And they were still having some of the issues. So what we did is we actually ran some of the data and said, hey, from a conversion standpoint, how are people converting when they go to the website? And so what we found, so this is an example, it's called a sunburst chart, but these are the paths to conversion. So like this path right here, if I scroll up just a little bit, you'll be able to see that the entry path for 5.13% of the conversions was from this path, which is a traditional path. Go to the product page, put something in the shopping bag, sign in, do your payment, bill, order, review, confirm. That's a traditional path that you would think a lot of folks would utilize. What we found, though, if you look at this path is really just order, confirm, and end. So that's not something you wouldn't traditionally see in a retail, right? When you're going to do a performance test case, you don't think you're just going to go submit and then order. That's usually, I've never run into any customers where that was a performance test case for them, even in the top 10. And yet here, what we found was that 37% of the conversions were done from that exact scenario. And when we backed up and brought this information to marketing, what we found was we figured out why. So what this retailer would do on a Sunday morning on their Facebook page, they would put a coupon that was good for that coming Friday, which happened to coincide with when they were having all their performance issues. And that coupon would be good from 8 to noon, and at 8 o'clock, 8 a.m., it would be 40% off, 9 a.m., 30, and so on until it went to 0. And then the code would, one week it would be women's clothes, another week women's shoes. So what was happening all week is the people that knew about that coupon essentially were doing things like the search, the product, and they'd come and visit the page, but they wouldn't buy anything all week. And then on Friday at 8 a.m., they would do that. go to cart, buy. And it was just fascinating to learn that, you know, we hadn't been testing that, but the test issues we were having coincided with that Facebook marketing. And so because we were able to do something like this now, we were able to go back and write test cases and drill down into this, including scenarios that, you know, were even, you know, more different than that one. And, you know, not everybody does the lengthy ones. But we're able to actually look under demographics and see other things. They had folks can sign up, so when they get to the web page, they say sign up for an account. So we're able to actually see demographic data, male, female. So another thing we found out that was very interesting, and they started doing the Facebook targeted ads towards this as well, is men and women shop differently. And when I first heard that, I was like, no, we don't. Online, it's all the same, right? You know, so what they found that women do is essentially what I just walked you through. The women are the ones that would take the Facebook thing and they put one, okay, I'm going to put a dress in there on Sunday. I'm not going to buy it because the coupon's on Friday. On Monday, I need some accessories. So now I need a blouse. I need shoes. I need a purse. And all week they would put stuff in, and then Friday they'd hit the coupon. What men would do, and this is kind of how I shop, is I'd go on a website. Okay, I need a pair of Dockers. I'm gonna buy them right now. Dockers, boom, buy them, done. I need a belt because I don't have a brown belt for khakis. Go back, buy a belt. What men do is kind of hit and run. Or like I do it, I always compare it to like when I shop at Lowe's. I need to buy a hammer. Go buy a hammer because I'm going to redo my deck or something. And then, oh, geez, I didn't buy any nails. I've got to go buy nails. So I have like 8 different single transactions that I've done at the site. But that's traditionally how men buy, and that's the data that we were able to pull out of this. And this wasn't the only retailer that we noticed this for. I noticed it for Lowe's, and again, there's 3 or 4 others that are also in the retail space, that same kind of thing. But it's fascinating data because what you're able to pick out is not just performance now from user measurement, but what they're doing and how they're doing it. So you can then tailor your test cases, tailor your test plans, but also now you can tailor your marketing. You know, maybe now you don't want the men to do a hit and run, so you got to do something that would make them, you know, purchase more, buy more at the one sitting. But that's one fascinating way of looking at real user data. Let's see if I've got some of the other ones here. Yeah, so this is another one that was very, so what this is just where do they begin? But again, same thing, it's just, you want to know things like where are they converting, where do they begin, where do they spend their time. It's just different function calls for different sets of data, you know, however you want to slice and dice it. But what it helps you do, now I could actually use this data, either that one or if I go back to the previous one here, I could actually say, this is my test plan. Here's my first test case. I'm going to go, and I'm going to go to order confirmation, then I'm going to go to submit. There's a test case. I'm going to go traditional route, and I'm going to go product page, shopping bag, sign in, and check out. Maybe another one is I'm going to go and do searches. But this sunburst chart essentially becomes your test plan. And it actually shows you the percentages that you need to distribute your test plan based on how people are using your web and mobile site. And again, all of this sits in Redshift, and you do the function calls with Julia. You can do this on your own, like you collect your own real user beacon data. But I found that fascinating, that now I can actually write my test cases based on data that I'm able to pull and analyze. And that's just one set of visualizations. So if I show you another one. Here's another one where if I just want to be able to pull out the number of concurrent sessions by month, so I'm looking at, you know, distribution, beacon distribution by month, what's the peak sessions, peak number of beacons, hour, minute. So I'm able to actually look at when the site's being used and the load across that site. And again, simple function with Julia right here, concurrent sessions by month for all of the beacons that you've collected within that month. And you can set the time. You can change the time anytime you want to look at a different slice of data, a different day, a different month. Maybe you saw something when you were running, you know, and you're essentially running the environment. You saw, hey, a little performance degradation on a certain day. You want to go back and look at what might have caused that, what they were doing. You're able to do that here. So the other thing you can do, and I can slice and dice the visualization another way, is if I wanted to actually look at the top 25 page groups for this web web page, website. Again, another example of a different visualization. 27% is product page, 21% category. So you're able to actually look at page groups, the number of visit types, how folks are, again, where they're hitting it, and and if I go scroll further down, I know it has number of requests. So you can actually look at what folks are doing on your site, which are the most ones that are hit, and again, it impacts your performance tests. And that's another similar one. I think I did 2 of them on that one. Also, conversely, if I want to actually look at top landing pages, where are they coming in when they land? Same thing. Is it the home page? Is it something else? Is it the go to cart and submit? This is a pretty critical one. If I want to actually look at conversion rates by load time, I want to be able to see, hey, how long are people waiting before they convert, and where do they start dropping off? So this is your conversion rate. I can actually look at the conversion rate against number of sessions, and then non-converted as well. So I can actually see where's that spot where people are bailing and not converting. You could slice it by page as well, but that one was session. And then here's sessions if you want to look at where your traffic is coming from. This one's particular is by operating system. You got Windows, Mac, Android, and iOS. So this kind of give you an idea of what devices and where they're coming from. And then conversion by device. Interesting was, one of the things we looked at as well was right around the holiday time, we were doing some data analysis, again, very similar to this, where the customer wanted to know, hey, is a majority of my traffic coming from mobile? Is it coming from web? And what are the time periods? And what we were able to do is to dig into the data, and what we found was on weekends, the majority of the conversions were coming from desktops. And yet during the week, the majority of the conversions were coming from mobile. And what we figured out is people aren't at work during the weekend, so they're at their desktops, and during the week they're kind of under the meeting room table making purchases apparently. But that data was pretty consistent all from several retailers through Black Friday right through the peak season toward the end of the year. And then we can actually rank page groups by the negative impact to conversions. So in other words, is the full page load time impacting the conversion rate for that particular page group? So I showed you the past before. Now you can actually slice the data to actually see, is that page group and the load time impacting conversion rate? And this one's fascinating. So you've got all this data, and essentially, really the only thing I really want to know is I want to know all that data put together, whether it's an operating system or an app, or the site, or a page group, or page, or whatever's causing all the problem. I want to correlate all that, and I want to deal with the things that are bad behavior. So this is essentially a cluster analysis, and like here, you've got this particular cluster is everything in the United States, and it's performing. Yellow is it's performing okay. Say you drill down, a cluster of red is something you want to look at. So, from Mexico, these page groups against these devices, against these operating systems have performance issues, and you need to drill down on the red. So it groups essentially by types of data, and so that you can drill down and see, okay, this particular common thread, Android running, or say iOS running 8.3 from Mexico on this network, that's having issues. Drill down, and I'm going to show you a visualization that does that even better. But the cluster analysis kind of can help you get there. So essentially what this has, it literally is all the potential data points, whether it's Windows, the page groups, the operating systems, the devices, what browsers you're coming from, and what location you're coming from, and what network. So what you want to be able to do, what this chart helps you do, is if I know that if I see red, like right here, and you see a response time like that, I want to be able to see everything in that thread that's essentially causing that to be bad. So here, it's a certain internet running a certain operating system from a certain location. And what it does is it gives you the ability to correlate all that. And the interesting thing is when we actually did this with one of the retailers, we did it against data that was all conversion. So we could see where the conversions dropped off, what was red, what was yellow, what was green. And they had every single transaction that they had done. And we were doing it for Black Friday. And this retailer I was telling you about with the Facebook page, I actually shopped there. And for Black Friday, I did grab my wife a bunch of stuff. But we were able to see here, and it had the city, and it was in red. And I remembered it was really slow. And it actually had my city, and it had everything. And when we were able to drill down, it actually knew it was right on which operating system I was using, my phone, time of day, what I bought, and what the transaction was and that it went through. So it was fascinating that they had my city on there. But you're able to actually drill down to that level because you're able to correlate each individual beacon, each individual transaction to drill down, and it helps you analyze what exactly has gone into that. Why is that path red? What happened? And this is a great chart for doing that. Again, you can build any of these. And then one other one I kind of want to show you for kind of future standpoint here. So this is actually MPulse. This is we were actually able to put all the graphs that I've showed you. Not only can you, you can do everything I've just showed you, you can do with Redshift and Julia, just like I showed you. What we do with MPulse and Workbench is we actually can correlate that and put that on a dashboard like that, and you can analyze that inside MPulse. This is the cluster analysis I showed you. That's the dimensions that I showed you, and then essentially the correlation chart. Yeah, I mean, you pretty much can develop any kind of, all these visualizations that I've shown, there's a whole, you can pretty much create anything you want to. I mean, if you came to us and said, hey, I want it to look like this, and I want this data slice, can you do that? Yeah, we would just write a function call and a visualization around that.
Are they from your API? Are they from your API, or are they just built in, well, we had to write ourselves in Julia?
So the ones that I showed you, we wrote them, so they'd be available to you. Anything that we write, we make available. What they are is they're functions put into notebooks. People in the community write them as well. And the idea is that everybody would write. Somebody's going to want essentially everything we just saw here. That's we may have done it for one customer, but it's available to all of them. And if you come to us and say, well, hey, I'd like to be able to have certain type of visualization with this kind of data, yeah, we'd write it and then provide it to you, and it'd be available to anybody. I haven't had a customer come to us yet and say, I want to do this, this, and this, and I want it to look that way, and we say, no, we haven't done that yet.
So you mentioned at the beginning that about 50 to 80% of the time of a data scientist is spent on cleaning up the data. Can you explain a little bit more about how the data that you are seeing here go from clickstream to clickstream beacon to Redshift, how that process works?
Yeah, so the slide I showed with the collected, I didn't spend a lot of time on it, but essentially they're all collected. The slide that kind of was the round circle. The MPulse architecture, what it is 3-tiered, so it collects all the beacons essentially from all the locations, and then we actually store them in 2 clusters in the United States and actually store all that beacon data. We don't drop any of it. And then all the correlations and functions that we do with it, we essentially do here. There's a whole bunch of algorithms underneath.
So let's say I have a group of web developer. What do they need to do to actually set up those beacons? Like what's special about, what do I need to do to actually plug into this functionality?
So to actually collect the beacons, you'd have to do it with our MPulse product. I mean, you could do it, I'd imagine you could probably do it with any other product, but with what I'm showing you, we provide, MPulse essentially collects that, so that's what's under that is the old boomerang log normal technology. We collect the beacons, upload them into the database that we have, and then what we do is the Redshift Data Science Workbench, we upload that every night. That's where you can actually do the data analysis that you see here, so it's kind of a 3-tier. But yeah, you'd have to have the capability to actually tag the page to be able to collect the beacon, store it somewhere, real time, ideally, and then be able to upload it essentially churn it here.
Just to reiterate, because I thought it was fascinating, when you saw the conversion, you saw the highest percent of conversion from users that had a full cart, they waited, and then they went straight to that page, and they converted on the day because of the coupon.
Yep.
Right?
Yep.
Were you then, was that the same behavior for full sites and mobile?
Yep. Yep.
Wow.
Yep. And I've seen it a lot, not just with the retailer we first saw it with was a women's clothing store in the Southeast. I'll say that. But I've seen it at I can mention Lowe's because that's yeah. And there's a whole bunch of other examples, but it was an eye opener because having that data to be able to show that to marketing, the marriage between IT and marketing happened right then and there. Because they're like, well, wait a minute, we do this all the time. Can you actually do this? Yeah, you can sit here and watch it live. Because that's what's going to happen. And when we actually did it, essentially re-scoped the performance test based on what we found, we did find a lot of stuff that we weren't finding with the other paths. But the paths we were getting was, well, this is how people use our site. Well, we didn't have the data before to say no until we did this. And once we had that, it's like, here it is. That's what people are doing. And it's been pretty consistent in marketing now. Essentially, they're all over that. And they do different types of coupons now, and they do Facebook coupons and Twitter coupons, because it's all social media. I mean, everything's driven social media now with marketing. And you have to adapt so quickly, push changes out, push the content out, if they're pushing a new line, because you see failures all the time. I mean, Target with Eli Lilly. Even the Prime Day with Amazon, that's a whole other separate conversation, but you have to be prepared for that, but it's a marketing driving what you see in performance. Right, exactly.
Sorry, I have one more question. In terms of real user monitoring, are you able to, let's say, track a specific user's behavior, and then say this person visits this t-shirts a lot, and then were we able to query your beacon to get the data back about that specific user and then do something with it?
Yeah, we're able to monitor that, but a lot of the retailers, they actually kind of, they do that with a lot of other products. We're able to do it, but if you've ever been to a site, say you go to Office Depot, and I keep listing all the ones that are my customers, and say you buy a printer. Well, what happens when you're buying that printer is something will pop up and it'll say, hey, users that bought this paper and this cartridge and all that. It's called rich relevance. And that, if you just look that up, it's actually a real company name. And that's actually what you're talking about. And then there's another, say you buy that printer and you leave and you come back, it will recognize that you did that and say, hey, last time you bought a printer, you bought a paper yet? You have a cartridge? So there's products that do provide that. Based on content and delivery on the page, more than from a marketing perspective. The answer is yeah, you could look at that data and slice and dice it that way, but marketing probably has some stuff that does that already, and rich relevance being one of them. I know there's 2 or 3 other ones, but that's just the one that pops into my mind because it's the pretty one that's got most of the market. It's trivia time. So Julia is a language you would think is a language named after a woman, correct? You think Julia? It's actually not. So when I did this trivia question, there is a language, and I've got 3 prizes I can give. Usually what I do is I make you tweet it to me, and the first 3 that tweet it to me get the charges, even if I have to mail it to you. But there's a language that was developed mainly for Department of Defense, and that's actually an example of it right there. I used to actually be a developer in it when it first came out. Now here's where I date myself. 2 compilers were developed for it, 1983 and 1995. Don't say the answer. I'm going to show you if you tweet me there, the first 3 people that get the answers right get one of the chargers. And then the other, also if somebody wants to get it and they don't know the answer to it, name the company I was working for in those timelines. It's an aerospace company. And just tweet me, and I'll follow you. If you follow me, I'll follow you back. And that's all I had for tonight. I tried to be respectful of your time and stop right at the hour. Hope you weren't bored by the jumping around with the screens. I just tried to show as many different visualizations. I could show you another 40 or 50 of them, but you get the idea. The things you can do with the real user measurement data, just they're amazing. And it just, in a lot of the customers I was with, a lot of them didn't understand why the real user measurement was so important. Oh, I have Omniture, I have T-Leaf, I have this, I have that. When they saw that, especially with the sunburst, it was like they had new friends in IT. It was amazing. And now what they use it for is to essentially help drive their marketing campaign. So it's a good marriage. The question was, what makes Julia suitable? Speed. I mean, R and the other ones I had up there, I think Python, the compilers are 20 years old. I mean, look at the technology that you're using. I mean, is there anything in your pocket that's 20 years old? The compilers are slow. We did benchmarks against them. What you saw there were industry benchmarks as well. But we were looking for, with the amount of data that we're putting in there, we needed to be able to do all the analysis near real time. And we just weren't getting that with R. We tried it with Python. It didn't work. Julia being, I mean, I think they're still on like version 0.5. But we've wrung it out. We found problems with it. But it wasn't enough to stop what we did. And it hasn't impacted what we're doing at all. And they resolve things pretty quickly. We're plugged into that community. But yeah, I would highly, for everything I've seen, all the different languages that were available. And of course, we looked at Hadoop, right? There's a lot of hype around that. I'm sure that's great, but not for what we're trying to do. So what we do, and I think I have the slide where we actually, every week, take the data from Impulse and put it into Redshift. That's where we do all the analysis work. So it's not really going in and out of Impulse. That's where we solve that problem. That's the issue you have with Hadoop. I'm trying to think of some of the stuff we do. How many beacons, like we can download, like we do, typically download a day's worth of data, and the visualizations that you saw here came up in a few seconds, and I'm over the cloud onto my laptop. So it's very quick. I mean, if you want to do something where you're crunching, say, a month's worth of data, where did I do that? It took maybe, because I did some work for Office Depot, and they wanted something specific, and I think it ran like half an hour, and we did like a month's worth of, we had to do a sunburst start. They had to have that for a month that we didn't have. It all depends on how many beacons you collect, your number of page groups, what's tagged. What's been open sourced, and then what's been done with the Impulse platform. So Impulse, essentially, that's where we collect all the beacons, we store them all, and then what we do with Data Science Workbench, the components of that, so you've got the storage component, so we pull the data out of Impulse, put it into Redshift. That's open source. You can get an account on Amazon. And then all the visualizations and functions you see, they're all written in Julia. That's what's open source. Now, if we write functions and visualizations, we make them available to the community, so then they become open source, and people are writing in the community builds, much like Python and some of the other stuff that's out there. But the notebook schema and idea has been around for decades, because the other languages have done the same thing. So you can do the same thing. You've got to get your real user data from a product and put it in, and then that's the 50 to 80% of the time, kind of crunching that I talked about earlier. What we do is we do that for you, but then the stuff underneath is open source, but there's nothing stopping you from doing the open source.